Hey guys, what's up? In this video, we'll be talking about a lot about priority queues, and also, you know what's interesting? We're gonna talk about external sort and selection sort. Welcome back to another episode of Strickler Googler. In this channel, we'll be talking about interview questions, giving you all the tips, all the things that you would need, all the resources, and we really want to focus on career growth. You know, we do a lot of interviews and letting you know what's out there, what new technology, and also we do some company tours. Stay tuned, and if you're new to this channel, please subscribe and smash that like button if you like the stuff here. That will really help the channel. And if you have any questions, anything new that we didn't cover, you know, just leave in the comment section below and tell us what you want to know. Let's jump right into the video. So today's question, we're talking about, given the list of integers, how to sort them. So how do you find what's the most fundamental of sorting algorithms? And then we're gonna dive into, given that the list is huge, right? The size of array is huge. How do you actually sort them if your memory is only 1 GB and you have 10 GB of integers? And then with the priority queue follow-up, I will be asking, can you find the top k numbers rather than using n log n? Can we do it using ON, using selection ranking sort? And let's get right into it. So first, let's talk about the question, right? What kind of sorting algorithm you want? A lot of candidates will focus on different sorting algorithms that they might know, but I don't think that's the preferred approach, because never in my interviews I have been asked, you know, about a particular sorting algorithm. So even though if you mention it, that would be fair game, but they wouldn't be asking you how to actually implement like a merge sort. Maybe they will ask you to do quick sort, just because a lot of selection ranking sort and all that will be really similar, but I would dive deep into it. So in this video, then let's talk about the first approach of brute force. How would you do it if the array size is huge? So given the array size, right, is like 1, 2, whatever, and then it's huge, gigantic array, and it's 10 GB. So we cannot read everything at once. So what can we do? As a brute force approach, what you can do is you can actually first chunk them up into different small size, right? And then making sure each of this chunk that you separate into, making sure all of them are actually sorted first. So now at least you have 10 chunk of 1 GB array that's sorted, and you can use any sorting algorithm. You can do merge sort, you can do quick sort, you can do any type of algorithm. The importance is all these chunks should be sorted first, and then after you sort all these chunks up, you want to merge them, and then making sure you can actually write it to some sort of output, making sure you can have 0 to n, right? So now the question becomes, given 10 string of integers, can you actually merge them? That would be the question. So you kind of, from external sort type of problems, you kind of identify how to do it using this approach. And then for the brute force approach, basically it's just you just loop through them, and then you find the smallest, and then you find the whatever array, you just get the next number, and you loop through it again, find the smallest. Whichever array that you pick from the minimum, you get the next number, and then you loop through them. So for that approach is, you know, big O of n m, because you actually try to get the number every time for each numbers in. So you have n numbers, and then for each numbers you have to go through n array to check which one is the smallest, right? So that's kind of, you know, the high level. So the second approach, right here, is we are given again, same thing, 3 different chunks of integers, of sorted integers, but we're building a min heap or whatever priority queue. So in each queue size, you will see here we have the value and the null, right? And you kind of build this min heap up, and then you just take the min, and then you get the next null from the string, and then you put it in the min heap. Inserting to a min heap is just log n, and you have n elements, and then you can just find the min. So that way it's actually n log n, but the heap actually only, if your heap size is only k, it's only gonna be m, right? It's only just gonna be the size of how many lists you have. So we actually is n log m rather than n log n. Now let's talk about the third follow-up, right? It takes us n log n time to find, the minimum for every single one of them. But what if we're trying to find the top k numbers? How would you do it? We can use min heap, but that is not very efficient either. Min heap in this case would do n log n as well. So how do we find the top k numbers? In this case, we can use selection, rank, and sort. The idea is, given a pivot, right? We want to put everything that's bigger than this pivot on the right. Everything in this pivot, smaller than this pivot, to the left. So let's say the pivot is 3 here. If it's smaller, you just stay there. We just move to the next index. If it's bigger, what happens is you swap with your next integer, and then you swap again. So now your pivot. So now 5 is gonna be on the right of the 3, and then whatever, and then 6 is gonna go back to where 5 is, because we haven't checked that number yet. So by the time you finish looping through it, you're gonna have an array where left side is smaller than the pivot, right side is bigger than the pivot. So what is the runtime? So by average case, amortized case, we're gonna pick the middle for most of the time. So every time when you pick, it's gonna be O(n) for you to sort half, and then another half n to find the top a quarter. So this is the O(n). Get it? So you have n plus half n plus a quarter n. So in the end, this is gonna be smaller than 2n. So this is gonna be big O of n. Boom! Hey guys, the question of the day. What's your favorite sorting questions? Leave in the comment section below and let me know what you want to cover next time. Hey, thanks for checking out the video. Hope you really like this video. Smash that like buttons, and please, if you're new to the channel, click that subscribe button. Just subscribe. Did I say that again? Subscribe. Did I say that? Subscribe. Okay? Subscribe to the channel. We have a lot of amazing videos. We recently just did an interview. If you want to check out the interview with the Intel CVP, just click right there. And for more interview tips, check out the video over there. We have a lot of more questions coming up. Until next time, keep crushing it. I will see you next time. Peace.